Welcome to a new session of MOOC on Information Security. Today we will discuss Trojan horse and trapdoor. We have studied the concept of the Trojan horse in our previous classes. In this session, we are going to study it in detail. A Trojan horse or Trojan is a type of malicious code or software that looks legitimate but can take control of your computer. A Trojan is designed to damage, disrupt, steal, or in general inflict some other harmful action on your data or network. Unlike viruses, Trojan horses do not replicate themselves, but they can be just as destructive as anything. One of the most insidious type of Trojan horses is a program that claims to rid your computer of viruses, but instead introduces viruses into your system. Trojan horse viruses can also be considered as a kind of malicious software that can perform various activities in the system of legitimate users that can harm them in any way. Some Trojans are designed to steal bank details, some are designed to work with downloading and installing other malicious software, while some are developed to install adware and so on. This term was first used in reference to malicious code in a 1974 US Air Force report on the analysis of computer system vulnerabilities. However, the term first became popular in the 1980s, especially after Ken Thompson's lecture at the ACM Turing Awards 1983 reception. For what was once regarded as a brilliant trick and a masterful feat of engineering is now regarded as a malicious digital pest whose sole purpose is to wreak havoc on computers of its victims unnoticed. It does this by reading passwords, recording keyboard strokes, or opening the door for further malware that can even take the entire computer hostage. These actions can include deleting data, blocking data, modifying data, copying data, disrupting the performance of computers or computer networks. Trojan varieties. We classify Trojans based on what they are capable of doing. It all depends on the Trojan's malicious code, also known as its payload. When a Trojan infiltrates a device, its payload carries out its tasks, which usually fall under one of these categories. A backdoor Trojan. A backdoor Trojan enables an attacker to gain remote access to a computer and take control of it using a backdoor. This enables the malicious actor to do whatever they want on the device, such as deleting files, rebooting the computer, stealing data, or uploading malware. A backdoor Trojan is frequently used to create a botnet through a network of zombie computers. Banker Trojan. A banker Trojan is designed to target users' banking accounts and financial information. It attempts to steal account data for credit and debit cards, e-payment systems, and online banking systems. Distributed Denial of Service (DDoS). These Trojan programs carry out attacks that overload a network with traffic. It will send multiple requests from a computer or a group of computers to overwhelm a target web address and causes a denial of service. A downloader Trojan. A downloader Trojan targets a computer that has already been infected by malware, then downloads and installs more malicious programs on it. This could be additional Trojans or other types of malware like adware. An exploit malware program contains code or data that takes advantage of specific vulnerabilities within an application or computer system. The cyber criminal will target users through a method like a phishing attack, then use the code in the program to exploit a non-vulnerability. Fake antivirus Trojan. A fake antivirus Trojan simulates the actions of legitimate antivirus software. The Trojan is designed to detect and remove threats like a regular antivirus program, then extort money from users for removing threats that may be non-existent. A game thief Trojan. A game thief Trojan is specifically designed to steal user account information from people playing online games. Instant messaging or IM Trojan. This type of Trojan targets instant message services to steal users' logins and passwords. It targets popular messaging platforms such as AOL Instant Messenger, ICQ MSN Messenger, Skype and Yahoo Pager. This malware can be used to either install Trojans or to prevent the user from detecting the presence of a malicious program. The components of InfoStealer Trojan can make it difficult for antivirus systems to discover them in scans. A mail finder Trojan aims to harvest and steal email addresses that have been stored on a computer. Ransom Trojan. Ransom Trojans seek to impair a computer's performance or block data on the devices so that the user can no longer access or use it. The attacker will then hold the user to organization ransom until they pay a ransom fee to undo the device damage or unlock the affected data. Similar to a backdoor Trojan, this strand of malware gives the attacker full control of a user's computer. The cyber criminal maintains access to the device through a remote network connection which they use to steal information or spy on a user. A rootkit Trojan. A rootkit is a type of malware that conceals itself on a user's computer. Its purpose is to stop malicious programs from being detected, which enables malware to remain active on an infected computer for a longer period of time. A short message service or SMS Trojan. The Trojan infects mobile devices and is capable of sending and intercepting text messages. This includes sending messages to premium rate phone numbers, which increases the cost of a user's phone bill. Spy Trojan. Spyware Trojans are designed to sit on a user's computer and spy on their activity. This includes logging their keyboard actions, taking screenshots, accessing the applications they use, and tracking logging data. How do Trojans impact mobile devices? Trojans are in problems only for laptops and desktop computers. They can also impact your mobile devices, including cell phones and tablets. In general, a Trojan comes attached to what looks like a legitimate program. In reality, it is a fake version of the app loaded up with malware. Cyber criminals will usually place them on unofficial and pirated app markets for unsuspecting users to download. In addition, these apps can also steal information from your device and generate revenue by sending premium SMS text. One form of Trojan malware has specifically targeted Android devices, called the switcher Trojan. It infects users' devices to attack the routers on their wireless networks. What's the result? Cyber criminals could redirect traffic on the Wi-Fi connected devices and use them to commit various crimes. Protection from Trojans. Here are some do's and don'ts to help protect against Trojan malware. First, the do's. Computer security begins with installing and running an internet security suite. Run periodic diagnostic scans with your software. You can set it up so the programs run scans automatically during regular intervals. Update your operating system software as soon as updates are made available from the software company. Cyber criminals tend to exploit security holes in outdated software programs. In addition to operating system updates, you should also check for updates on other software that you use on your computer. Protect your accounts with complex, unique passwords. Create a unique password for each account using a complex combination of letters, numbers, and symbols. Keep your personal information safe with firewalls. Backup your files regularly. If a Trojan infects your computer, this will help you to restore your data. Be careful with email attachments. To help stay safe, scan an email attachment first. A lot of things you should do come with a corresponding thing not to do, like do be careful with email attachments and don't click on suspicious email attachments. Here are some more don'ts. Don't visit unsafe websites. Some internet security software will alert you that you are about to visit an unsafe site. Don't open a link in an email unless you are confident it comes from a legitimate source. In general, avoid opening unsolicited emails from senders you don't know. Don't download or install programs if you don't have complete trust in the publisher. Don't click on pop-up windows that promise free programs that perform useful tasks. Don't ever open a link in an email unless you know exactly what it is. How to identify a Trojan horse? Since Trojan horses frequently appear disguised as legitimate system files, they are often very hard to find and destroy with conventional virus and malware scanners. Specialized software tools are often necessary for the identification and removal of discrete Trojan horses. However, it is possible to identify the presence of a Trojan horse through unusual behaviors displayed by a computer. The quicks can include a change in the computer screen, including changing color and resolution, or an unnecessary flip upside down. Excessive numbers of pop-up ads will appear offering solutions to various errors, which might prompt the end user to click on the ad. The computer mouse may start moving by itself or freezing up completely, and the functions of the mouse buttons may reverse. The browser's homepage may change, or the browser will consistently redirect the user to a different website than the one they are requesting. This redirected website will often contain an offer that users can click on or download, which will in turn install more malware. The computer's antivirus and anti-malware programs will be disabled, and the necessary steps to remove malware will be inaccessible. Mysterious messages and abnormal graphic displays may start appearing. Unrecognized programs will be running in the task manager. The taskbar will either change in appearance or completely disappear. The computer's desktop wallpaper may change, as well as the format of desktop icons and applications. The user's personal email service may start sending spam messages to all or some of the addresses in the contact list that frequently contain malware, and a persuasive tactic to get recipients to open and download the attack, thus spreading the Trojan horse to other computers. Next, we discuss Trojan removal. If a Trojan horse is identified on a computer, the system should immediately be disconnected from the internet, and the questionable files should be removed using an antivirus or anti-malware program or by reinstalling the operating system. The hardest part of the removal process is recognizing which files are infected. Once the Trojan has been identified, the rest of the process becomes simpler. Users can sometimes find the infected files using the dynamic linking library DLL error, which is frequently presented by the computer to signify the presence of a Trojan horse. This error can be copied and searched online to find information about the affected exe file. Once the files are identified, the system restore function must be disabled. If this function is not disabled, then all the malicious files that were deleted will be restored and will infect the computer once again. Next, users must restart their computers. While restarting, users should press the F8 key and select Safe Mode. Once the computer has successfully started up, users should access Ads or Remove program in the control panel. From here, the infected programs can be removed and deleted. In order to ensure all extensions associated with the Trojan applications are removed, all of the program files should be deleted from the system. Once this is complete, the system should be restarted once again, but this time in the normal startup mode. This should complete the Trojan horse removal process. Where did Trojans originate? Trojans can come from practically anywhere. An infected flash drive, an email, a hijacked website, and so on. However, history indicates that most Trojans come from these sources. File sharing sites. File sharing sites are useful, but they have downsides. One is that hackers can upload cracked copies of legitimate software injected with Trojans and wait for unsuspecting targets to take the bait. Email attachments. A single click is all it takes for a Trojan to attachment to infect a computer. If you open the infected attachment, Trojan malware will be downloaded and installed, and it will then do what it is programmed to do. Infected websites. If you visit a hijacked website, malicious codes injected into it will take you to another malicious website or install a Trojan. Hacked Wi-Fi. Hacked Wi-Fi or even a fake Wi-Fi hotspot made to look like a real public hotspot can give hackers easy access to your device. If you are connected to one, the hacker can execute all kinds of attacks on your device, like installing backdoor programs or rats. Well-known examples. One of the first Trojan to become widely known was also the first ransomware seen in the wild, the AIDS Trojan of 1989. This malicious code was distributed via postal mail on floppy disks that purported to contain an interactive database associated with the disease AIDS. If installed, the program waited 90 boot cycles and then ciphered most of the file names in the root directory of the machine. The licensing agreement of the software demanded that the victim send $189 or $378 to a post office box in Panama to get their data back. The notorious spyware FinFisher, also called FinSpy, is another example of a Trojan. It is known for its extensive spying capabilities and misuse of webcams, microphones, keylogging, and ability to exfiltrate files. It is marketed by its developers as a law enforcement tool, but it is believed to have been used by oppressive regimes as well. To hide its true purpose, FinFisher uses various disguises. In one of its campaigns, discovered by ESET, it posed as an installer for popular and legitimate programs such as browsers and media players. It has also been distributed via emails with fake attachments or fake software updates. Now we will move on to trapdoor. A computer trapdoor, also known as a backdoor, provides a secret or at least undocumented method of gaining access to an application, operating system, or online service. Programmers write trapdoors into programs for a variety of reasons. Left in place, trapdoors can facilitate a range of activities, from benign troubleshooting to illegal access. Because computing systems are complex structures, programmers usually develop and test systems in a methodological, organized, and modular manner, taking advantage of the way the system is composed of modules or components. Often, programmers first test each small component of the system separate from the other components in a step called unit testing to ensure that the component works correctly by itself. Then developers test components together during integration testing to see how they function as they send messages and data from one to other. Rather than pasting all the components together in a Big Bang approach, the testers group logical clusters of a few components, and each cluster is tested in a way that allows testers to control and understand what might make a component or its interface fail. To test a component on its own, the developer or tester cannot use the surrounding routines that prepare input or work with output. Instead, it is usually necessary to write stubs and drivers, simple routines to inject data into and extract results from the components being tested. As testing continues, these stubs and drivers are discarded because they are replaced by the actual components whose functions they mimic. Poor error checking is another source of trapdoors. A good developer will design a system so that any data value is checked before it is used. The checking involves making sure the data type is correct as well as ensuring that the value is within acceptable bounds. But in some poorly designed systems, unacceptable input may not be caught and can be passed on for use in anticipated ways. For example, a component's code may check for one of the three expected sequences. If it finds none of the three, it should recognize an error. Suppose the developer uses a case statement to look for each of the three possibilities. A careless programmer may allow a failure simply to fail through the case without being flagged as an error. The finger flow exploited by the Morris worm occurs exactly that way. A C library input-output routine fails to check whether characters are left in the input buffer before returning a pointer to the supposed next character. Causes of trapdoors. Developers usually remove trapdoors during program development once their intended usefulness is spent. However, trapdoors can persist in production programs because the developers don't forget to get rid of them. They intentionally left them in the program for testing purposes. If you intentionally leave them in the program for maintenance of the finished program, or intentionally leave them in the program as a covert means of accessing the component after it becomes an accepted part of a production system. Prevention of backdoor attacks. A backdoor virus attack can go undetected for a long time because they are pretty difficult to detect. That's how hackers design them. Even so, there are a few easy steps you can take to keep your device safe from backdoor virus attacks. First one, use an antivirus. Sophisticated antivirus software can help detect and prevent a wide range of malware including Trojans, crypto hackers, spyware and rootkits, frequently used by cybercriminals in deploying backdoor attacks. Another step is download with caution. When downloading software, files or apps, pay attention to the permission request to install free additional bundled applications. These are called PUAs or potentially unwanted applications. Free software, files and apps that appear to be legitimate but are not. And they are often packaged with a type of malware including backdoor viruses. Use firewalls. Most antivirus software is equipped with a firewall that can help protect against attacks such as backdoor viruses. Firewalls are designed to monitor all incoming and outgoing traffic on your network so they can filter out threats. Use a password manager. A password manager can help you generate and store login credentials for all of your accounts, as well as assist you in automatically logging into them. Password managers use a master password to encrypt your password database, so you don't need to type in your password, email or username every time. All you have to do is save your password in the password manager and then create a master password. Keep up with security updates and patches. Hackers abuse unknown flaws or weaknesses in a device or software. These weaknesses can exist because of a lack of updates. Statistics show that 1 in 3 breaches are caused by vulnerabilities that could have already been patched. Use multi-factor authentication or MFA. Multi-factor authentication is designed to improve security by preventing unauthorized access. It requires you to confirm your identity in more than one way when accessing an application, website or software. MFA uses 3 essential elements to prove your identity. Something that only you know, like a password or PIN. something that only you have, like a token or your smartphone. Something that only belongs to you, like your thumbprint, voice or facial features. So far we have discussed in detail the Trojan horse and trapdoors. Hope you enjoyed this session. See you next time. Until then, bye.